When the personal computer was first introduced, they were largely standalone devices. You would have one on your desk, or you may have one at home, but they generally didn't communicate with other personal computers. As they started to proliferate in the marketplace, however, the idea of being able to share information became a really appealing idea. The first network was actually called SneakerNet, which may sound a little strange, but the idea was you would get a disk out of one computer and you would walk over and give it to another user, hence SneakerNet because of walking. What started out as just simple disk exchange has evolved to astounding levels. We have all types of networks today. We have local area networks, wide area networks. There's the internet where you can literally talk to someone on the other side of the world. And it's a very complex topic, but it's something that is absolutely part of the computing landscape today. And you as a network professional need to have a degree of comfort with networking. So let's take a look at what's involved and really understand how all the pieces fit together.
I actually began my career in the internet service provider industry and actually went to work for a very large company where I dealt with sales representatives selling long distance. And I remember at the time I wanted to try to find a way to be able to help them grasp at least some basic ideas of how networks operated. And so I actually came up with some ideas about how to communicate the networking fundamentals type of principle. From a basic standpoint, the internet is usually referred to as the information superhighway, with a road such as you see right here. And that actually provides a perfect backdrop for understanding how computer networking operates. And to be completely honest, the internet is the ultimate network in terms of capability and complexity. Ultimately, using this imagery of travel on roads and highways illustrates the process of network-based communication in explicit detail. It expands the concept of interpersonal communication across times and distances, and there's certain experiences that you will have during travel that mimics network communication. For instance, there are certain reproducible steps that happen every time we travel on a road or highway. We start out at some point where there's a street address. In my particular situation, I live in Auburn, Washington, and if I want to go anywhere, I have to get into a vehicle. That vehicle transports myself and whoever else might be with me. Now, when I want to actually travel, I have to get to the on-ramp on some sort of highway. And at that point, I'm able to get on to the highway and able to navigate to wherever I want to go. Now, in my particular route of travel, I may cross several highways, and when I get to a certain point, I know that I want to get off the highway because I'm nearing my destination. So I will actually take an off-ramp. I will exit off of the highway. I'll come to my destination. Again, there's another address. Then I'll get out of the car and I will have arrived at the destination. Now, strangely enough, you can apply all of this to a network setting. You start out with a source address. It's not a physical address, but it's a logical address. You've seen these decimal numbers, no doubt, anytime you've been dealing with the internet. And instead of it being a vehicle or a car, it's a packet that's transporting information. The information is placed into the packet. It then gets on some sort of access link to the network. It could be an Ethernet cable, it could be wireless, it could be your smartphone, but that medium is used to access, in this case, the internet. And if you're trying to access, for example, some sort of web server half a world away, the destination address in that packet is how that packet knows how to travel to that particular network. Essentially just getting off another access link, again wired or wireless, and to that particular destination where it arrives. Now, that being said, there are different types of networks that you'll encounter. The first involves one device or a personal computer. Using some sort of wireless, in this case Bluetooth, you can actually access printers, smartphones, a mouse for example, and other devices such as laptops. This is what's referred to as a PAN or personal area network because it's all concentrated around one person or one individual device. It's not designed for long-distance communication. Next, there's another type of network to look at, and this is called a local area network. Local because it's actually connected together in some fairly geographically close proximity, within a home, within a building, within an office. And typically there's some sort of network medium, usually a cable of some sort, actually helping everything connect. When you actually look at these types of networks within a close geographical area such as a city, you can actually have what's called a metropolitan area network, meaning that they're all within one metropolitan area. Then of course you could have these same types of networks that span the globe. and this is called a wide area network. So personal area network, local area network, metropolitan area network, and wide area network. And to be completely honest, sometimes the words metropolitan area network and wide area network, the distinction can be a little fuzzy, so just keep these in mind. Next, it's important to understand some different topologies. In other words, how the network is actually constructed. The first type of network is called a bus topology. This was actually employed in some of the very first Ethernet networks that actually had a single coaxial cable, and stations would attach to it, and you actually had to have resistors on the end. It's called a bus because everything is on the same electrical circuit. Another type of topology is called a ring topology. Now, ring topology is pretty much obsolete because the main technology that used this was called token ring, which I can almost guarantee that you will never see. It's been obsolete for a number of years, but that's another way of looking at topologies of a network. You also have a star topology because there's some device at the center, a hub or a switch or some other such device, and everything fans out in a star pattern from there. Now, these are physically looked at here, but if you looked at the logical, it would actually look more like a star. And have you ever connected devices together? This is called a peer-to-peer topology. This can be direct connection, one computer to another using a device called a crossover cable, or it could be just simply sharing in a peer-to-peer fashion. For instance, there's a lot of peer-to-peer file sharing programs, but this is another topology to consider. In addition to network topologies and network types and technologies and so forth, you're also going to encounter something else in just about all the literature you'll read about networks, and this is called the OSI model. OSI stands for Open Systems Interconnect or Open Systems Interconnection. In any case, this is usually how the logical pieces of the network are actually described. It's important to know what these mean. So first you have what's called the physical layer, and these are usually labeled 1 through 7. At the physical layer, the data unit that's involved are bits. Bits are actually the on or off, the ones and zeros that travel across the wire as electrical impulses. And so typically the kind of devices that you're going to see at layer 1 or the physical layer are going to be hubs because all they do is retransmit information. The second layer, or layer 2 of the OSI model, is called the data link layer. There's a lot more detail to this, but these are just the high points. And the unit of data is called a frame, Ethernet frames, wireless LAN frames, and so forth. And typically, switches are used at the data link layer. Layer 3 is the network layer, and layer 3 uses packets for sending and receiving of data. And typically, you're going to look at routers at layer 3. Layer 4 is called the transport layer. Typically, when you hear of protocols such as TCP and UDP, you're looking at the transport layer, or layer 4. The type of data that's used at layer 4 is called a segment, and typically routers are involved at layer 4. Now, layer 5, typically you're just using user data. The same thing for layer 6, which is the presentation layer, and the application layer, which is layer 7. These are all the various parts of the OSI, or Open Systems Interconnection model, and each one of these describes a logical part of the way the networking process operates. Now that we've talked about the OSI model, let's just talk about some typical devices that you will probably find in a network. Even though you're a PC technician, you'll frequently interact with these types of devices. So first we want to look at layer 1. Remember, layer 1 was the physical layer. And there's a device called a hub. What a hub basically does is it creates one electrical bus. Remember, we talked about bus as a topology type. Anything that's input into the hub, it just sends all the way back out the other ports. So pretty much all it does is basically repeats what it hears. You can kind of think of it as a copy machine in sort of a digital form. It just takes what it hears and it reproduces it electrically exactly as it received. And this is the process you see pictured here. This workstation is transmitting, and then the hub just sends everything back out to every other station. That's pretty much how it works. And this is what a hub basically looks like. Next, you have layer 2 devices. You have what's called a bridge. Bridges had 2 ports and basically used the type of logic that allowed it to be able to filter traffic. In other words, if you had one LAN segment with a hub on one side and one LAN segment with a hub on the other side, it would actually be able to determine whether or not it needed to send it across the bridge. It would actually build a table dynamically. It's an older device. You won't find bridges anymore. Instead, you'll find switches. Switches actually are like multi-port bridges. They actually have advanced capabilities. They can transmit at wire speed. You can actually create virtual local area networks and do all sorts of other things. There used to be switches that only operated at the LAN or layer 2 level of the OSI network. Those were layer 2 switches. More popularly now available are layer 3 switches. It's really beyond the topic of what we want to deal with here, but we did want to at least give it a brief treatment to give you an idea of the nuances with these types of networking devices. And then you have wireless access points, which are layer 2 devices, which you can have computers that don't have physical connections but can use radio waves to communicate. The lower half of the network is wired. The upper half of the network is wireless. This is very common in most networks today. So another layer 2 type of device. This is a generic access point. Then you have layer 3 devices. You have your switches here and different networks, and you have a router that joins everything together at layer 3. And again, these are much deeper topics by themselves, but this is designed to be introductory to give you an idea of the types of devices that you'll encounter. And that's a typical Cisco router. In this case, it's a 2620, which is an older device. Then you have internet connectivity of various types, what's sometimes called a modem. Now, strictly speaking, a modem was a device that modulated and demodulated, but DSL and cable and other types of internet access, which we'll talk about in a separate lesson, are sometimes called modems because they're actually access devices. Then finally, you have a device that actually protects you from the internet, because the internet basically is unprotected, and that's called a firewall. It permits certain transactions to pass and others not to pass. That essentially ends up protecting you from hackers. Now, speaking of firewalls, I do want to clarify something. When I talk about your firewall protecting you from the internet, it's technically attackers on the internet that are your actual threat, mainly because the internet is open and allows for free communication. You can actually have those with ulterior motives wanting to attack a given organization. So the internet as a whole is neutral, but those that use it sometimes are not. However, the threat is usually from the direction of the internet because of those types of attackers trying to exploit things. And this is an example of an ASA 5505 firewall as manufactured by Cisco Systems. So let's summarize. First, a LAN is a local area network. This is a computer network composed of devices in close physical or geographical proximity, typically a room, a floor, a home, a building, and so forth. A WAN, or wide area network, is a computer network composed of devices in different geographic locations. It could be across town. It could be across the world. A hub is a LAN device that allows more devices to connect to the network and just simply retransmits received signals to all devices. And finally, a switch is a LAN device which allows more devices to connect to the network, but only forwards traffic between specific ports based on the MAC or hardware address of attached devices.
Isn't it fascinating how information can go from one side of the globe to the other across all of these connections? It's something we take for granted today. I remember growing up without answering machines, without cable TV, and without the internet, and those are just all given so many times today. We can have internet at home, we can have it on the go on our cell phones, we can even be flying at 30,000 feet and be on the internet. It's a wonderful technology that gives us a lot of advantages. Thanks for listening.